6.2 because, yesterday it's just like a lot to understand. E is some kind of number, an irrational number. We're approaching 2.718, and there's all these other digits that come behind that. And then we graph with it, and we use the compound interest formula, compound continuously, which makes sense because when you're compounding all the time, you can't put a number for n in, and it's just approaching infinity. So we would use the E and placement there. What we're going to talk about today is just how to simplify expressions that have E in them, and this would be without a calculator. So I don't want decimal answers, I want answers that are in terms of E. Okay. Now, let's recall from Algebra 1 some properties of exponents. So basically, we're using our old properties of exponents. Does anybody know what I mean when I talk about properties of exponents? What am I referring to? Like adding the exponents. When do you add your exponents? Can you give me an example? When you're multiplying two powers. Okay, so if I had like x squared times x cubed, that would be x to the fifth. What are some other properties you know about? When you divide them, you subtract. So we could either write this as x to the 2 minus 3, which would be x to the negative 1, or what is x to the negative 1? 1 over x. So that's another property of exponents. If you have a negative exponent, it flips what it touches, so the x moves to the bottom. And we have a placeholder 1.
When you add them.
Do you add x squared and x cubed together? No. Do I multiply them? Mm-hmm. Well, I could multiply them over here, right? Add the exponents. What do I do with this? Leave it alone. These are not like terms, so there's nothing to do. There is no property of exponents for adding and subtracting two powers. Okay, powers are the things that have the base and the exponent. Oh, yeah, you've seen that one before. Like, let me do x squared cubed. And what do you do with your exponents there? Multiply them. So x to the 6, I have to be careful there, so I won't add them up and make x to the 5th again. Yeah, we did that actually. Probably that was a new one back in chapter 5. It was our last chapter, I think, of chapter, or our last chapter of semester 1. So remember when we would do things like, what is the cube root of x to the 6th? X squared. We could really write that as like a fraction exponent. The root is always in the denominator. So this is like x to the 6 over 3, which is x squared. And like technically we could do like what's the cube root of x to the 7th? That was the one where we were like, okay, well, 7 divided by 3 doesn't go in very nicely, but I could take the cube root of x to the 6th, right? That would be x squared again, but then I would still have one cube root of x left over. That wouldn't be able to come out of the cube root. It doesn't have enough to make a cube root. So that, like you divide, and however many times you can get 3 into 7, that gets to come out. So we can get it in twice, but what's the remainder when you do 7 divided by 3? 1. So 1 remains inside. Okay, good. Anything else you remember for properties of exponents?
Anything raised to 0 is 1.
Oh, sure, yeah. So like x to 0 is equal to 1. Okay, good. Anything else? There's two more, and they would be something like this. Suppose I had x cubed, I'm going to change it over y squared. And then I raise it to the 4th. That property just says that you raise the numerator to the 4th and the denominator to the 4th. If it's in a group of parentheses, that's the power of a quotient. that you apply it to both. So this is like x to the 12th, y to the 8th. And the same thing for something like 2x cubed. If I square that, we've done that before numerous times, like when we did binomial expansion with Pascal's triangle, that this is like 2 squared and x cubed squared. So it's really 4x to the 6th. So those are all properties of exponents. So now we're going to apply them to things that look like this. And what I don't want you to do is put it into the calculator and give me decimals. Don't want it. I just want you to use your properties of exponents. So I'll let you jot these 3 down and you can kind of check with your pod members. What do you think the answers are? We'll say our answers here in a little bit. Remember, don't give me any decimals, just give it to me in terms of E.
Second and 2e squared out and got 9e are
Okay, let's check our answers. First one, e to the 7th. When you multiply powers, what do you do with their exponents? Add them. Keep the base, add the exponents. So this one should be e to the 7th. All right, this one over here, 10e cubed over 5e squared. 2e, right? 10 over 5, those are regular numbers, so reduce them as you can. So that's 2 over 1 or 2. And then we reviewed that property if you're dividing things with the same base, subtract their exponents. I always ask myself, like, where are there more e's on the top or the bottom? Top. So then I'm going to keep e in the numerator and it'll be e to the 1st. You can just write that as 2e. You don't have to have to the 1st, but I won't take off if you do. Okay. What'd you guys get for 3e to the negative 4x squared? 9e to the negative 8x. Use your negative exponent property. What flips? The e only. Is the negative affecting the 9? No. So this would be 9 over e to the 8x. Now, technically, most of the time, like back in Algebra 1, when you were simplifying with properties of exponents, they'll ask you to like have all your exponents be positive. So if you get a negative, flip it wherever it belongs. Only flip the part that has the negative exponent. So don't flip the 9 if it's not affected by a negative exponent. Okay. All right. Try these. Okay, let's chat. First one, 2e to the negative 5x raised to negative 2. Well, this negative 2 affects everything, so what happens when you do 2 to the negative 2? It turns into 1/4. And then when you, what should you do with your exponents right there? E to the negative 5x to the negative 2? Multiply, so you're going to get positive 10x. So I would write this as e to the 10x over 4. Now you could also write 1/4 e to the 10x. That would be fine. Those are the same thing. This means like 1/4 times e to the 10x in the numerator, not in the denominator. Okay, what will we do over here? 1,000
Over e to the 9x.
over e to the 9x. Awesome. Okay, the negative is going to flip only that piece. And this one's going to be 3e cubed. So mix and match different properties. Just think about where things go. Take as many steps as you need. That's what your homework is going to be. So I would imagine after your concept check, you might be able to finish.
That's it.
Oh, concept.
I got multiple points.